Hi everyone. In this video I will show you what the dependency Bazelizer is all about. First, let's start maybe by running the dependency Bazelizer. In order to run it, we need to provide two input arguments. First is an input list, and second we have an s3 config.json. I will run it and then explain what those are. So the input list is a list of Debian package dependencies, similar to what we can see here, and it has Debian packages that we want to turn into Bazel modules. And the dependency Bazelizer not only turns that into a Bazel module, but also the entire transitive dependency graph of each Debian dependency listed. So everything is turned into a Bazel module, and those Bazel modules can actually reference each other and interact with each other. And then the dependency Bazelizer makes each module an HTTP archive, uploads it to the S3 bucket that we provided the config for here, and then creates a registry where it adds a reference to the modules that have been modularized, right? As we will see shortly. So now, as you can see, not only the IP route 2 has been modularized, but also its entire dependency graph. And if we go to the registry now, maybe let me reload quickly. If we go to the registry now, we will see the modules. And as you can see here, we have IP route 2, and it's not only modularized, but also each and every transitive dependency is also a module that is referenced here. So basically now Bazel can take care of resolving the entire dependency graph of the IP route 2. AMD 64 here is just because modules don't represent architectures. Okay, I claim that the IP route 2 now is not only modularized, but also ready to be used. It can find its transitive dependencies in the run files without any extra work. I will prove that claim later. But first, we need to tackle the problem that this is not an extensible solution now, right? Because imagine you having a module with two other submodules. The module needs to use the dependency Bazelizer, and the submodules also need to use the dependency Bazelizer. And that would mean that each module will actually end up with its own registry and then uploads to an S3 bucket that they know the credentials for. And that's just not extensible, right? Because at the root module, you don't know the credentials for the S3 bucket of a submodule, for example. Also, you will have a lot of redundancies in what's being represented and referenced. So in order to make it extensible, I came up with the solution to add an extension that you can see here. And this extension is basically a collector of configs. So what it does, it collects the input file from each submodule as shown here, and then concatenates all of these input files where Debian dependencies are listed into one big file, and then uploads it to the S3 bucket of the root module. And then in the root module, it adds a registry where the entire Debian dependency graph is represented. Let's take a look how that looks like. So basically this is the demo module, right? So let's assume that this demo module is a module that uses the dependency Bazelizer, right? As we can see here, you can see that we have the dependency Bazelizer, and then we have the dependency, the extension of the dependency Bazelizer that is actually providing us with a tag class config to which we can add the input file and the S3 config file. All right, but this module also happens to have a submodule, transitive dep module, that also uses the dep the dependency Bazelizer, right? As you can see here. And it's also providing its own input file. In that input file, it lists that it wants patch elf AMD64. And in our root module, we list IP route 2 as the Debian dependency that we want to modularize. Now let's see what happens when we run the dependency Bazelizer through the macro that exposes it here inside of the demo module. So let's go to the demo module and then basilisk run dependency Bazelizer. So now, as you can see, we don't need to provide the input file in the S3 config because that's the point of the extension, right? It is already provided. And this run Bazelizer is actually, as you can see here, it's simply exposing the dependency Bazelizer target. So let's take a look now. So as we see that we have the IP route 2 and all of its transitive dependencies, but we also have patch elf, which is the dependency listed in the transitive dependency module. All right, and now we can see that there is a registry in the root module, and inside of this registry, all the modules, all the Debian dependency graph is represented. Now, before I said that the IP route 2 dependency is in fact ready to be used, and I'm going to prove this in a second. So I went to the .bazelrc and I told it, okay, I will have a local registry under workspace registry, so please refer to that for modules. And then if I go here and I use IP route 2 as a dependency and go into this demo, right? Let me show what I'm trying to do. So in this demo, it's a very sophisticated demo where I called it IP route 2 demo. I'm calling the IP route 2 as a data dependency. And then inside, I'm just simply doing this very sophisticated move. But what it proves when I run LDD on the IP that is inside of the run files, what I'm trying to prove here is that the IP here will actually be using the transitive dependencies that are baselized already and not the ones on the system. And in order to do that, I will try and run this demo. Demo, and then we called it IP route 2 demo. Nice. As we can see, the dependencies that are being accessed are not from the system, they are from the run files. Basically, the transitive dependencies that have been modularized by the dependency Bazelizer. That's all I have to show. Thank you for watching.